So in this video, we're going to talk about functions and what is a function. How can we tell different ways to identify what a function might be? So first, a relation is just a set of ordered pairs. It's kind of that definition there. A function is a set of ordered pairs. So basically what this is saying here is it's a relation where the input only has one output. Only one output. That's really important. For a function, whenever you put something into a function, you only get one thing out. And we'll look at a few different examples here of what are functions. We'll start out with some things that aren't really mathy, and then we'll get into some math examples of a function. So a function is always a relation, but not all relations are functions, because all functions are a set of ordered pairs, which are relations. So let's look at the first example here. Let's get rid of this little deal. And our first example is people and their weights. And so each person, I've got it by name, Amy, Beth, Carly, Darla, and Emily. Each person has one unique weight. So Amy doesn't have two different weights because at this moment when Amy took her weight, she was 145. Beth was 130. Carly was 145. Darla was 162 and Emily was 117. So just because Amy and Carla had the same weight doesn't mean this isn't a function, because the input is the person, and typically that's kind of our x in our function, and then the output was the weight, which is typically our y if we're looking at it in terms of x and y. So this would be an example of a function that isn't super mathy, but to get the idea of each input, the person, only has one unique output. So this is not a function, fruit and their color. So if we have apples, we could have red apples, we could have green apples, there are yellow apples, there are probably some purple apples out there. So each x, or fruit, or input, can have multiple y's. So even though apple is an input, it has multiple outputs. And so this one would not be a function because some of the inputs have more than one output. Grapes are different colors. Lemons are yellow typically. There might be some lemons that are not yellow. But regardless, if an X or an input has multiple outputs, in this case, that's the case, this would not be a function. All right. So here's a more mathy example. Which of these are functions? We've got two examples here. The first example has a bunch of points, -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. And then example 2 has the points listed there. So the first example, I would say, is a function. This is a function because, let's drag this, there are no, there are no repeating x values. So this one is a function because the input, each input, the x value, has only one output, the y value. Yes, some of the y's repeat, but that's okay, as long as the x's do not repeat. And then likewise with the second one, this is not a function because -1, if you notice here, it is paired with 2, and it's also paired with 4. And so -1, it has two different outputs that cannot be a function. There are a couple different ways to label or to name a function. In the previous example 1, we just listed out the points, and so sometimes you'll list them the way I had on the previous slide. Sometimes you'll list them in brackets like I have here. Other times you might just list them as a table, as an x, y table. It doesn't always have to be x and y, but most of the time we use x and y. So it'd be -2, 4, -1, 1, 0, 0, 1, 1, and 2, 4. You could graph this if we're using x's and y's. So we go back 2, up 4, and make a little dot. We go back 1, up 1, make a dot. We go 0, 0, 1, 1, and 2, 4. So we would have, this is a graph of 5 dots, basically. It's very tempting to want to connect these dots, but We're not given an equation here, we're just given 5 dots. So this would be a way to graph it by just plotting 5 points. And then you could make an equation of this. If you notice, all of the y's are the x values squared. And so the equation would be y equals x squared. However, we're only dealing with these 5 points. And so we have to say where x is an integer. An integer is like a whole number, but it can be positive or negative, in case you forgot what an integer is. Where x is an integer between -3 and 3, and then we would say exclusive, which means it doesn't include -3 and 3. So it's any integer between -3 and +3, not including -3 and +3. You could write it as an integer between -2 and +2. And instead of saying exclusive, you could say inclusive. That's another way of saying it. And there's probably a more concise way of saying what I'm saying right now. And then the last thing we're going to talk about is how do we tell just by looking at the graph if something's a function or not. And so remember, we talked about we cannot have any repeating x values. And so what we're looking for on these graphs is, does an x value have 2 different y values? And so if I look at this first graph, like right here when x is 0, there's a point at the bottom of the graph and a point kind of at the top of the graph. This would not be a function because when x is 0, y is either 2 or -2. So that one's not a function. And anywhere we have a situation like this, that wouldn't be a function. And so oftentimes what you'll see is what's called this vertical line test. And the vertical line test for a function is the graph of a function will never touch a vertical line more than once. And so what you do is you take your pen or your pencil or whatever you have, or you just make a line, and you run it across the graph from left to right. You take this vertical line and we just move it across the graph and test to see, is this a function? So if you notice on this first one, do you see how that graph crosses that fuchsia line twice? That means it's not a function. So this would not be a function because it crosses that graph twice. Pretty much everywhere until we get to -4, and then it crosses it once at -4, and then to the left of that it doesn't cross it at all. However, anytime it crosses it more than once, that automatically fails it. It fails to be a function. So the second example here, this one is a function so far. It's only crossing once the whole time. Crossing once, crossing once. It looks like this thing would be considered a function because it never crosses this vertical line at twice at any given spot. So that one's a function. The third example down here, it only crosses once, once, once. Yep, it's still a function, still crossing once. And yeah, this would always be a function unless it went straight vertical at some point, but I don't think it will. So this one is a function. So that one's good. And then this last one, this one, it's a wave. This is called a sine wave. But this wave, it always crosses that vertical line just one time. So 3 of the 4 are functions. So we would say no to the first one, and then yes for the other 3, because they pass the vertical line test. And oftentimes that's all you need to say. If there's a question where they say, is this a function? You say yes because it passes the vertical line test, or no because it fails the vertical line test. So that's a brief crash course on functions. What is a function? How do you identify one? And just kind of what you need to know about the basics of a function.